Lesson 37, using scientific notation. Here in the picture here, you can see using scientific notation. And why would we use scientific notation? We would use scientific notation to write numbers that are either really, really big or very, very small. And they all have a lot of zeros involved with it. And so we use scientific notation to make the numbers a little bit, to be able to read them easily. We write them in scientific notation. And so normal numbers bigger than 1 or large numbers always have a positive power of 10. And so we have to make sure we use a decimal point, a decimal number, and the decimal has to be between 1 and 9, so like 6.2. And then we're going to be multiplying it by a power of 10. So if the number is bigger than 1, you're going to have a positive exponent. If it's less than 1, then you're going to have a negative exponent on your power of 10. So let's look at some examples here. Scientific notation to standard form. Standard form is just what is the actual number. So 1.08 times 10 to the second, that just means we move the decimal point 2 places to the right, which would give us 108. 1.08 times 10 to the third, I move it 3 places, so this would be 1080. 1.08 times 10 to the fourth, I move it 4 places, so this would be 10,800. Times 10 to the fifth, move it 5 places, it would be 108,000. So all we're doing is just tacking on another 0 at the end of our number for standard form. Now if we have a negative exponent, we move it to the left that many places. So we move it to the left 1 place, so it would be 0.108. 2 places to the left, it would be 0.0108. 3 places, 1, 2, 3, would be 0.00108. And to the negative fourth, 1, 2, 3, 4. So we get 0.000108. So with the negatives, you're always adding a 0 for each place in front of your number, making the decimal smaller and smaller. So now let's write in scientific notation. So I have 856,000. I need to have a decimal between 1 and 9. So the decimal point is here, so I move it 1, 2, 3, 4, 5. So it's 8.56 times 10. We moved it 1, 2, 3, 4, 5 places, so it'd be 10 to the 5th power. It's a positive because our standard number is greater than 1. Our next one, our standard form is less than 1, so I know I'm going to have a negative exponent. So let's move this decimal point to 1, 2, 3, 4. We moved it to the right, so I have a decimal that's bigger than 1 but less than 9. So this would be 5 times 10, and I moved it 1, 2, 3, 4. So it would be a negative 4. Next one is 4,900,000. This would be 4.9, because I have to have one digit to the left of the decimal point, and it's got to be greater than 1. So 4.9 times 10. Move the decimal point 1, 2, 3, 4, 5, 6. It's a positive 6 because I have a number greater than 1. Other examples. Here I got a lot of zeros here, so this is where the scientific notation, writing it makes it a lot easier to read. So I have 1, 2, 3, 4, 5, 6, 7. So I move it 7 places. So 9.3 times 7, or 10 to the negative 7th, because it's less than the standard form of the number is less than 1. 1,234,000 would be 1.234 times 10 to the 1, 2, 3, 4, 5, 6. Positive 6. And the last one here, it's less than 1, so I know I have a negative exponent. 0.12, so 3.06 times 10 to the negative second power. Now what do you do when you multiply in scientific notation? When you multiply in scientific notation, you multiply the decimals by the decimals. So 5.7 times 1.8 equals 10.26. And then we multiply the bases. When we multiply the bases, remember you add the exponents. So this would be times 10 to the 8th. But our answer has to be in scientific notation. Our answer is not in scientific notation because our decimal is not between 1 and 9. So I have to move the decimal point 1 to the left. So really the answer is 1.026 times 10, but it's not 10 to the 8th. Because now we have to change the exponent. Since we gained a decimal place, we have to show that we gained a decimal place with our exponents. So since we moved it to the left, we gained a decimal place, so I add 1 to my exponent, so it would be 10 to the 9th. The bottom one, 3.2 times 4.3. So 3.2 times 4.3, I have 13.76. And then times 10 to the 9th, because I add the exponents. Again, this is not in scientific notation. I need to move it 1 to the left. So it'd be 1.376. Since I gained a next decimal place, I gotta show that I gained 1. So I add 1 to my exponent, so it'd be times 10 to the 10th. And that would be my answer in scientific notation. Let's do another one with multiplication. So 5.82 times 6.13 gives us 35.6766. This would be times 10 to the 14th. Need to put it in scientific notation, so I move it one place to the left, so it would be 3.56766 times 10. Since I gained the next decimal place, I show that in my exponents, so it would be 10 to the 15th. Next one, work with dividing. We do everything the same way. We divide the decimals, so 1.2 divided by 9.6 gives us 0.125 times 10. And when we divide bases, we subtract the exponents. So 2 minus 4, or 2 minus 6 would give us a negative 4. Well, my answer is not in scientific notation. I have to move it 1 to the right. So I lost a decimal place. So if I lost a decimal place, I gotta show that I lost it. So I'm subtracting 1. So my answer would be 1.25 times 10, and then negative 4 minus 1 is a negative 5. So I would have an answer of 1.25 times 10 to the negative 5th. Next one, 7.29 divided by 8.1 gives us 0.9 times 10, and I have negative 2 minus a negative 6 gives us a positive 4. I need to have my answer in scientific notation, so I need to move my decimal point 1 to the right. So I lost a decimal place. So I subtract 1, so this would be 9 times 10 to the 3rd power. And another division problem. 6.8 divided by 2.5. We have 2.72 times 10. 5 minus 8 is a negative 3. I have a decimal point that's between 1 and 10, so that's good. So we already have our answer in scientific notation. So we'd have 2.72 times 10 to the negative third. Now let's do some comparison. So we have 7.2 divided by 3.6 gives us 2 times 10 to the second, because 6 minus 4 is 2. That's already in scientific notation. The other one, 1.05 divided by 3.5 gives us 0.3 times 10 to the third power. I need to make that in scientific notation. So move it to the right one, so it's 3. I subtracted 1 because I lost a decimal place. So 3 times 10 to the second. So now you can compare your answers. 2 times 10 to the second would be 200. 3 times 10 to the second would be 300. So 2 times 10 to the second would be less than 3 times 10 to the second power. Next example, we have 4.56 divided by 3 gives us 1.52 times 10 to the fourth. So just subtracting 9 and 5. Over here we got 5.2 divided by 1.3 gives us 4 times 10 to the third. And if we want to compare, if you can't tell from scientific notation, you can always put it in the standard form. So if I were to put this 1.52 times 10 to the fourth, I would just move it 1, 2, 3, 4 places. So it'd be 15200. So 15,200. This one would be move it 3 places, which would be 4,000. So 1.52 times 10 to the fourth is greater than 4,000. And a couple application problems. The speed of light is 3 times 10 to the 8th meters per second. If Earth is 1.47 times 10 to the 11th meters from the sun, how many seconds does it take light to reach Earth from the sun? Write the answer in scientific notation. So we're going from light to reach the Earth from the sun. So we're going from the Earth to the sun. So we're going to set up as a division problem. So it's going to be 1.47 times 10 to the 11th divided by 3 times 10 to the 8th. And so we take the 1.47 divided by 3 gives us 0.49 times 10 to the 11 minus 8 is 3. I need to put it in scientific notation, so move it 1 place to the left, or to the right, so it'd be 4.9. I lost a decimal place, be times 10 to the second power. And that would be, how many seconds? This parlay would be seconds. And the last one here, the speed of light is 3 times 10 to the 8th meters per second. If Mars is 2.25 times 10 to the 11th meters from the sun, how many seconds does it take to reach Mars from the sun? Now remember the formula, rate times time equals distance, because you might have been wondering, how did I get the division problem? Since we're trying to find time, I divide by the rate, and time is the distance, and we're told that the distance is 2.25 times 10 to the 11th for Mars to the sun, divided by the rate. And they said the speed of light is 3 times 10 to the 8th. So that's how we set up our problem. 2.25 divided by 3 gives us 0.75 times 10 to the third power, because 11 minus 8 would be 3. We need to put it in scientific notation, move it 1 to the right. So we would have 7.5. We lost the decimal point. So times 10 to the second, and this would be seconds. So that is our lesson on scientific notation.